volume and the height, not the radius.
Yeah, does that make sense, you guys? In this case, the radius stays constant. So if you take the derivative and anything that, you treat that just like it's a value. If you take the derivative of it, it would be 0. So you could, like, if you get to a product rule this, but then the part where you did this thing, it would be 0. You know what I'm saying? So you can treat all of this as a constant now. Because it's not changing. It's just a number. Does that make sense, you guys? So whenever you do these problems, the first thing you can figure out is like, okay, I need some relationship. I'm filling water in. It's a cylinder. Do I know anything about volume of a cylinder? Okay, I have some equation. Then it's like, what information do you have? Well, let me make some stuff up here. Let's say I am filling this. What do I want to do here? The radius of my little cylinder is, this is what I have. Information I have. I have the radius is 4 inches. And I want to know and I also know that the height's changing at 2 inches a second. And I want to know how fast the volume is changing. Okay? So, what would this derivative be in terms of time? Talk about it in your groups and figure it out for me. d dt both sides of the equation. d dt both sides of the equation. What do you get? Give me what is our derivative equation? Change in volume over change in time equals, oh, I got two different things. I got 2 pi r and I got pi r squared. Which one is it, you guys? Do you want to show some answer? Yeah, if this is a constant, if it's never changing, what you really should do is plug it in right from the beginning. And then it'll actually, you can get rid of variables right from the beginning if you can. Okay, if it's not changing. So in this case, before I'd even do this, I would say V equals pi 16h. Do you know what I'm saying, you guys? If you can recognize what changes and what doesn't. Now, h is changing, so you can't plug in any h or anything like that. But if you know from the beginning what's not changing, what's constant, then make it that number if you can. It'll make your life easier. Okay? So then the derivative of this is 16 pi dh dt. So what's interesting about this, I think Nathaniel was noticing it, is that there's actually a direct relationship between the height changing and the volume changing. And there's no other, it's not in terms of the height at all. It's just a constant. Because if this is also, if I'm keeping real steady, this Gerard's really holding tight, 2 inches per second, and I plug that in, oh shoot, I should have done this. What's up? dV dt. This was, I wanted to show you the units again. So this would be 16 inches squared h, 16 inches squared. So this would be 16 inches squared times pi times 2 inches per second. And then you see the units again? You get cubic inches on top of volume divided by seconds, which is the time. So units match up. So this is what, 32 pi? Is that correct? 32 pi inches cubed per second. Any questions on that? Alright, I'm going to start this next problem and we'll finish it tomorrow. This is a fun one. Let me erase this. How's everyone feeling so far? Any questions? So this is one of the things that is the most hated out of all the calculus, just because it's really weird. And usually it's like one free response or one multiple choice. It hasn't really been popping up in the free response, Jackie. And we'll go through that like as that time of the test comes out. We start looking through what's been tested. But it's still something that it's kind of fun. You know, it's a little puzzle. It's what we do Friday nights. You know what I'm saying? It's like you figure out what's changing. What's changing? My feelings for you because I don't like you anymore. Opposite day. And it's like, you build it all in. It's all, I don't know, it's kind of fun. But opposite day. And then you get up because you forget. It's opposite day. All right. So, let's start this problem off. You got a person A and a person B. A is moving toward, they're on streets. These are two streets. He's walking towards the intersection at 2 meters per second. And then you got B, who's walking away from the intersection at 1 meter per second. Okay? Does everyone understand what's happening here? I got this knucklehead moving this way, and this guy moving this way. And what I want, I'm like, oh, you know what would be interesting to figure out? How is that angle changing then between them? Would that be fun to figure out? So if you think about like what's happening with the triangle, so like this side's going down, so that this side's going down. And then it's coming out. You know what I'm saying? Like that. But it's at different rates. Isn't that fun? Yes? It is a little bit. A little bit. So so I want to know how fast is what I want is I want to know what the change in the angle is when A equals 10 meters, and B equals 20 meters. Okay? So what do I know? A, what? Okay, so change in A over time, I know dA dt is equal to 2 meters per second. But is the side of length A growing bigger or smaller? So that's got to be negative. Because it's decreasing. The size of that side length is decreasing. And I know that the change in the B length over time is equal to positive or negative? Yeah. So this side's getting bigger. So it's 1 meters per second, okay? And I want something to do with that angle. Is there anything that relates this, and that angle? I don't know. First I was thinking Pythagorean theorem. The tangent. So let's see. The tangent of that angle is equal to what? Opposite over adjacent. And I'm just going to, so you can either leave it in that form or either way, whichever you like, product, rule, or quotient, whichever you prefer. So what I want you guys to do is a couple minutes left, see if you can sort of get started on this problem. And what would you do? I want d theta dt. How can I figure that out?